Hi, I think we're back. That was a great talk by Dan Fernandez. If you missed it, you should try to catch that later. He just did a nice session about how you can use .NET and SignalR and some of the technologies there to control a Lego robot. So that was really cool. My name is Ben Lauer, and I'm from the Kinect for Windows team here at Microsoft. And I'm going to spend some time. I'm assuming that those of you that are watching this are most likely new to Kinect. And maybe you've played with Kinect a little bit. Maybe you have played with Kinect on your Xbox 360 or Xbox One. But I'm on the team that focuses primarily on all of the ways Kinect can be used outside of the living room, sort of beyond gaming. And we have a new sensor and SDK that's coming. Oh, the camera's over. Is this camera over here? Sorry, I'm being told I need to look at a camera, and I'm not sure which one. So, oh, the red dot. There it is. Perfect. So, I got some teleprompters coming in too. Great. So, hi, I'm back. I'm looking at the right camera. So, we've got a new sensor technology that we created last fall with the launch of the Xbox One. We've taken that same sensor and we have an SDK, full SDK that's going to ship in public beta this July. And the sensor is going to ship in July as well. And I'm here to talk about that. So we're going to cover off what's new in the new sensor and also in the SDK. We're going to take a look at a concept that we call data sources. So the Kinect actually has multiple sources of data that it provides that you can utilize in your applications. And we're also going to look at a tool in our SDK called Kinect Studio. My tagline here is planes, trains, and automobiles. If you're a John Candy fan, you might get the movie reference. And then we're going to take a look at Kinect interactions and then finish up talking about Kinect Common Bridge. So let's jump in. So if you're new to Kinect, I'm assuming most of you are, Kinect is a new kind of camera that can see in 3D. So there is a traditional webcam. I'm going to go ahead and hold the sensor up here. There is a traditional webcam or color camera, as we call it here on the sensor. But there's also a depth sensor. And that means that the Kinect camera can see in 3 dimensions. The bottom here is also a 4 microphone array. And this microphone array allows you to do some things. We're going to talk about how that works. But it allows you to essentially track different people in the room, pinpoint certain sounds and things like that. The SDK can do things like recognize when there's a person present. So you could think about what could your application do. This is very common in retail experiences where you may have ads running or content running, and then as soon as a person is detected, your app can change and can respond to that. Also, not only can you detect people, but we can tell you through our SDK the position of their body. We have 25 skeleton joints that you can map onto different people, up to 6 people actually. Mentioned the microphone, and there's lots more that you can do. So primarily, what's new with Kinect for Windows V2? I mentioned this, the new sensor shipping in July, shipping in 23 countries. I'm going to have a link at the end of the deck that I'll leave up if you're interested in how to pre-order that sensor right now. The public beta of our SDK will happen also in July, and we've had a preview program since last November where we've had over 4,000 people into that program from all over the world giving us feedback. They've had early access to the hardware and to the SDK as we've been building that out. Another new thing with Kinect for Windows V2 that you couldn't do with V1 is this is the first time you're able to publish applications to the Windows Store. So not only can you publish to Windows Store, you can still do desktop applications. We have full native support as we always have. There's full support for WPF. And then another new thing that we're doing is we're creating an official plugin for Unity 3D. So if you're using Unity for games or for any other types of applications, you can use our plugin. Makes it really easy to create desktop and store apps and get all the Kinect data into Unity. So let's talk a little bit about the changes that we've made in the new sensor. The new sensor has a much wider field of view, both vertically and horizontally. The old sensor had a motor at the bottom, and there was an API, and you could actually tilt the camera up and down. That was actually cool to play around with. But it was really there because the old sensor had a fairly limited field of view vertically. So the new sensor, much better on the field of view. We've increased the depth fidelity by about 3 times, and you're going to see this in a second, just how clean and how much you can see there in the depth image. The color camera is running at 30 frames per second, and it's full 1080p now, so 1920 by 1080 resolution, so big step up there on the color camera. The infrared technology is lighting independent. We've actually moved to a new technology called time of flight, if you're familiar with that, and we're able to subtract ambient light from the scene. And again, I'll show an example of all of these things. The microphones have improved over the V1 sensor. In V1, you could track skeletons for up to 2 people, and there were 20 skeleton joints. With the V2 sensor, you can get 25 joints for all 6 people that are being tracked. Plus, we've made a lot of improvements in the skeleton tracking. It's a lot more stable and more anatomically correct. We've added a thumb joint so you can track the thumb. We've added a new joint at the tip of the hand, and I'll give demos of these. And then we've also improved the range of operation with this new sensor. So we can actually give depth data as close as 50 centimeters all the way out to 4.5 meters. And actually in that operating range, you're going to get the full pipeline, skeletal tracking, depth and everything. And then we've also, in direct response to feedback from our preview program folks, we're actually going to have at launch extended depth out to 8 meters. So we think this is going to open up a lot of new scenarios as well. So before I jump into the data sources, I actually want to jump over and just do a quick demonstration here of what we call Kinect evolution. So Kinect evolution, and please forgive the sensor. My legs are actually hidden behind the table, as you can see here. So you'll notice that the skeleton, for example, is doing some wonky crab legs, as we call them. And basically what that's doing is because of the occlusion of the legs, you're still getting back the skeleton joints there, but it's just sort of the best guess from the SDK. So let's start by, actually, let's take a look over at, so this is the new color image. So you can see it's very wide, vertically and horizontally, again, full 1080p color. So quickly, we'll move through these. This is infrared data. So I'm actually here in the Channel 9 studio, so it's very well lit. But if we were in the middle of a cave and it was completely black, I mean, we're talking so dark you couldn't see your own hand in front of your face, you would still see this image that you're seeing now. And that's, again, because we're putting light out into the space and we're subtracting the other light out. So super clean IR image. The old V1 technology would have been very pitted, is how I like to describe it. You would get infrared data back, but because we were using different technology there, you would get that. So the IR is very clean. And then, am I not projecting the screen here? I am. Sorry, it looks like maybe I've was having an issue there. Can we see that now on the broadcast? Are you guys seeing the app now? Okay, perfect. So let me just jump back real quickly. So color image, I mentioned. I'm just going to jump through these quickly now. This was the infrared that I was just talking about. So again, you can see it's clean IR now using this new tech, the time of flight. So here's the depth image. And so if you ever saw the depth image off of V1, you'll notice right away just how clean this is and what level of detail. I mean, you can see the wrinkles in my shirt. You can see my hands. You know, I'm a good 2 meters, meter and a half away from the sensor right now. So you can see my face. You can see that you can make out my mouth moving. So again, 3 times the fidelity in this depth image than what we had in V1. So with that, I want to talk a little bit about the skeleton. So you saw this before, but I'm going to talk through this in detail. So one thing you'll notice here right away is we have these green circles on my hands. We actually have in V2 now, we have some hand states. So green is just indicating that my hand is open, my palm is open. Red is going to indicate that I'm making a fist or I'm gripping. And then we've added another hand state that we call the lasso, and the blue is indicating that basically my fingers are just, that both fingers are up like this. Let me actually do this in the color image so you can see that as well. So that's skeleton tracking, or body tracking as it's now called. You can't see it here because of the dots, or sorry, the green circles are covering it up, but we've added a tip of hand joint and a thumb joint to each hand. We've also added this clavicle joint that allows for things like shoulder shrugs. So you can see a tremendous amount of data there. We now have the another visualization here that we call Blockman. And what Blockman shows is we have full joint rotation on all the joints. So as I move my hands over, you can see I'm getting all that rotation information. If you could actually see my legs, or more importantly, if the sensor could see my legs, you could see that I could rotate my legs and whatnot. So this is great for things like character retargeting. So if I was going to do something, say like Unity 3D, I could have a full 3D model. I could then map joints of that model to joints of Kinect of the skeleton here, and then I could do that kind of avateering or character retargeting. So let me switch back over to the slides. And I have a feeling I'm going to need to restart this because we switched to duplicate. Are we good on the slides there? Okay, so we just talked about those data sources, again, coming from the Kinect. Actually, you know, one thing I did forget to show was down in the bottom right corner, that's the visualizer on the audio. And so if I were to come over here to the left side of the sensor, you see that it's indicating that that's now the direction from which the sound is coming. If I snap over there, snap my fingers over the right, you saw that directional change. So again, that array of 4 mics allow us to do what's called audio beam forming. And so you could, again, just kind of tune in your app and really just pay attention and get audio from one person or from a particular direction. Okay, so let's go through these data sources now. Again, here are a couple of my teammates shown, the same kind of view shown in all of the different sources that we just looked at. And just did the demo, but let's go through these sources in a little bit more detail. So the infrared data, or as it's called in the SDK, the infrared frame source, is a 512 by 424 array of pixels. It runs at 30 frames per second, and it comes in at 2 bytes per pixel. Again, the ambient light is removed from the sensor, and infrared is actually from the same physical sensor on the Kinect as the depth information. You could think about using this infrared, so like how you might use it is you might think of doing some sort of night vision application. If you're doing computer vision, people detection or object detection or things like that, this infrared gives you a nice, clean, consistent source. Again, that's not going to be affected by the ambient light in the room. Now, sort of the caveat here is that we're still going to have issues with direct sunlight. So you know, it turns out the sun's just really, really bright and really, really hot, and it's going to cause most likely interference for your application. There are some things that you can do to work around that. For example, we have one of our partners has deployed a Kinect solution inside of a showroom, and they put it on wheels, and so at a certain time of day they have it on one side of the room, and then as the sun shifts they can move it to the other side of the room. You can also put up curtains and whatnot, but again, using it in direct sunlight is most likely going to be problematic, and there would be workarounds that you could do. So the depth frame source is also 512 by 424 resolution, also at 30 frames per second. Again, we talked about that range being from 0.5 centimeter out to 4.5 meters. I didn't update this slide, but when we launch the SDK this summer, we will have extended depth out to 8 meters. And So we're excited about that addition. Color frame, again, 1920 by 1080. It's a different sensor on the camera or on the Kinect than depth and the IR. It runs at 30 frames per second, but there is an automatic mode where if the sensor detects low light, it'll automatically degrade down to 15 frames per second so that we can give you back a higher quality color image. We've got feedback from our preview program that folks want to have a way to always get 30 frames per second, and that is something that we're looking at. Body index frame source. Think about this as essentially the Kinect is able to tell you in that array of 512 by 424 pixels, it's able to tell you which pixels are associated with a person and which person. So again, we track up to 5 people. So it's going to be an array 0 to 5. It's a 0 indexed array of bodies. There's actually a property in the SDK called body count. So if you're into first-person shooters, you might think that's kind of funny. But basically what it does is it says, hey, at this pixel, is there a person detected? If not, it's -1, and if so, then it would be 0 through 5 that corresponds with that person. So that allows us to do things like, you could use this to do kind of an ersatz green screening, if you will. You could take and say, hey, I only want the color pixels where there is a person detected, and I want to remove everything else, and I want to put them, say, on the beach in Hawaii or something like that. And we have seen lots of applications like that. The body frame source. Now I want to spend a moment on this slide because this is showing on a skeleton all of the 25 skeleton joints that we have in the SDK. And the thing to remember here is each of the skeleton joints is actually given back to you with 3 dimensions. So you get X, Y, and Z coordinates for that joint. There's 6 people, so you can get the body masks that we just talked about. You can get that for 6 people, but you also have full skeletal tracking for all 6. This runs at 30 frames per second again, and then the hand states that we showed earlier, open, closed, and lasso, you get those for 2 people. Again, we have been asked by people in our preview program to do that for all 6, and that's something that, again, that we're investigating. Oh, I didn't mean to jump the slide there, sorry. The other thing that you can do is you can use this skeleton information to do something sort of like lean. And on the Xbox side, we actually have seen some folks make sort of like a third thumbstick. So the controller, you've got the 2 thumbsticks, but you can actually track the person's lean and do kind of like another analog thumbstick. So that's something else that would be available in applications. Audio frame source. Again, the data is audio samples that are just captured over the interval of time, and then that audio beam or that beam forming as we showed earlier, you can kind of steer that cone, if you will, into a particular area of focus. Some other features that I'm not going to be able to demonstrate today, we do have support for speech, so you can actually roll your own grammar and you can speech enable your application, so it could be things like navigation or additional speech commands that you might want to add. We have face tracking and HD face. HD face is actually, I think the number is just right around 1,400 individual points on the face, so you can get a nice super high quality face model of somebody if you wanted to use that in your application. You may have seen that on the Xbox and Kinect Sports Rivals. They do an excellent job using that. I mentioned earlier we have the plugin for Unity 3D, and then Kinect Fusion allows you to essentially take the Kinect and use it to scan objects or people or a desk or something like that, and you get a full 3D mesh of that particular person or object. So then that's something that you could use, like I said earlier, you could scan yourself and then you could take that 3D model and put it into Unity, and you could rig that up to the skeleton joints of Kinect, and you could have yourself as sort of a 3D model in a game. But you can also then send those objects into 3D modeling software, clean them up, 3D print them, and things like that. So first of all, I just want to say that we do require, because of the new sensor has so much data coming off of it, we do require a USB 3 port on the PC. We also, because of that USB 3 requirement, the support for USB 3 in Windows 8 is really, really good, and so we require Windows 8 and above, 8.1 for example, for the applications to run. So if you think about it, the sort of base level, we have the physical Kinect sensor, and then on top of that we have our drivers. We have a Kinect runtime that gets installed with the sensor and with the SDK. And then on top of that, we have a native API, so you could use that if you wanted to make C++ desktop, or if you wanted to make a C++, or use some other, if you had your own sort of UI framework, like, and I'm going to talk about this a little bit later, but like something like Open Frameworks and Sender, those applications are using C++. So you can use the native API there. We also have a .NET or managed API that you can use for WPF, for example. And then again, something that's new for V2 is we have a full WinRT API that allows you to target Windows Store, and you can use C#, VB, JavaScript. If you're an HTML, JavaScript developer, you can use those skills and target Windows Store. And then you can also do C++ CX apps. A change, an improvement that we've made over V1. In V1, you could only ever have a single Kinect-enabled app running on your machine. So with V2, we've changed the architecture of the runtime to where you can actually have multiple apps running simultaneously, all sharing the data that's coming off of the sensor. Okay, so here's some notes about how you would create a Windows Store app, for example, using Kinect. So, you install our SDK, and then you would go File, New Project, and target a Windows Store application. So you do have to enable in the permissions for the Store app, you have to enable microphone and webcam capabilities. Again, we have a mic array and the webcam, so you do have to enable those capabilities. And then for now, because we are in preview, and then again in July, for those of you that want to get your hands on the public beta, you would just add a reference to Windows Preview.Connect, and then you use that namespace in your code, and then you're off and running. All right, so that's sort of a high-level overview of the sources and the architecture. I want to spend some time talking about a tool in our SDK called Kinect Studio. So I'm really excited about this feature because I commute to work on the bus, and I can have my Surface out, or I can have my laptop out, and I can be writing code while I'm commuting. But frankly, it's a little bit weird, and it would just be impractical to just have to pull a sensor out and like try to position it and try to do anything like on the bus, right? Or on the train, or even if I was flying somewhere, using a physical sensor is just not practical, if not impossible. So what Kinect Studio allows you to do is you use a sensor and then you record clips. So these clips can be really short, or they can be fairly long. Now the clips, again, because of all the data coming off of here, the clips get really big really fast. But you essentially are recording all of the sources directly from the sensor into this clip file. And then you can play those back for debugging. You can use them for things like machine learning. If you wanted to, say, build your own custom gesture and you wanted to use machine learning for that, you would use Kinect Studio to record lots of people doing that gesture, and then you could apply some machine learning to that and again make your own custom gestures. But the other thing I want to mention here, and before I do the demo, is that we had Kinect Studio in V1, but in V2 it actually will run headless. And so that means that you don't have to have the sensor plugged into the machine itself. So in V1, you still, even though you were playing back these clips, you had to have the sensor plugged in. Now you don't even need a sensor present. So like I was saying, on my commute, I can have my recorded clips on my machine, and then I can just sit there and use those in my app. Now the other thing is, sometimes when you're programming, maybe you're lazy, but even if you're not lazy, it would be a real hassle to make a code change and then have to stand up, hit F5, stand up, back away from the sensor, do my thing. Oh, okay, I think I fixed it, or oh, I got to make another change. So Kinect Studio, again, allows you to just be more productive when you're there and you're actually coding and doing debugging. So with that, let me jump over and actually just run Kinect Studio. Okay. Okay, so here it is, and we've got Kinect Studio. This is the new UI for the new Kinect Studio. So you can see there's a tab here for recording, there's a tab here for playback, and then there's this log as well. If I come over here to File, I actually can choose Connect to Target. So what that's going to do is it's going to connect to my sensor that I have here. Now I'm presented with some options, and I know this might feel a little bit overwhelming at first, but these are the different data sources that we have coming off of the sensor. So I actually need to say which sources do I want to monitor, or which sources do I want to record if I'm going to do the recording piece. So let's say I want to look at the depth data, and I want to look at the body frame, body index. Let's just check them all. And then if I click over here to monitor target, so the sensor just turned on, the light came on, and I have a driver issue, which is always great in a live demo. Thank you. And let's see if we can get that to go away. Maybe not. All right, let's see if we get this to recover here. Did I mention that this is beta? It's pre-beta. Wow, this is embarrassing. Hopefully I don't get a blue screen. All right, let's close Kinect Studio and let's restart it and see if we get. Let's see if we can get back into that. All right, again, so I'll come over here. I'm going to connect to my target, do my monitor all these streams. So we should be monitoring now. Nope, not having any luck there. Okay, so I'm going to move on. Basically what I was going to show there was that the sensor, when you connect in Kinect Studio, you would actually see all of the sources showing up in Kinect Studio, and then again I can record those into those clip files. So let me disconnect from this, and Kinect Studio is acting up. This is what you always love to do during a live demo, is go in and manually end tasks here. So I'm going to try one more time to see if I can actually get the playback to work so you can see what that looks like, because I did record a clip earlier at my desk. And so here's a clip I recorded earlier. And so if I turn this on, I'm actually going to see if I can get this to loop a few times. I think we're here on a run into some issues with Kinect Studio. Well, very embarrassing. And anyway, what you would see if the clip was running is now you're seeing the live view from the sensor, but if that clip was working in Kinect Studio, you would actually see all of that data show up here in the Kinect Evolution app that I showed earlier. And again, makes my development time easier, of course, assuming Kinect Studio works. And it will at public beta, I promise that. But that's Kinect Studio. Let me close that down and we'll switch back over to the slides here. Okay, I think we have the slides back up. So there's a question that's come in for online. I'm going to pause for a second. Someone saying that they're new to Kinect, and what are possible uses / applications of Kinect besides games? And that's a really great question. Actually, that kind of gives me an excuse to jump to some slides I have. Let me just jump down to the end. So here's some slides that I put in case this kind of came up. So some of the things that we've seen on, commercially is we've seen across these sort of 5 industries, or these 5 verticals. Retail. So in retail, we've seen a lot of these. There was something recently that got play on like TechCrunch and Engadget, and it was around the Iron Man 3 movie, where people could go and the Kinect would see them, and then they would see themselves on screen with the Iron Man suit kind of being assembled onto their body. So there's some really cool interactive things like that that we've seen created. But also in retail, having a display that's just sort of there displaying information that then changes and can interact with a person, again, because the Kinect is present and can say, hey, there's a person present, now let's change the what's going on here. Physical therapy. There was a partner called Reflection Health that joined us on stage at the Build conference. And they are in clinical trials right now with using the Kinect to actually detect the skeletal position of the patient. So somebody can be at home and they're using this Kinect-enabled app to do their physical therapy and make sure that they're doing the exercises correctly, and then that data can be shared back to their physician through the cloud, and then they can prescribe changes or modify the plan. That's sort of also in healthcare, but also in healthcare we see things like in a dirty hands environment, like if you're in a clean operating room. You want to be able to gesture or use voice to navigate through some of the patient's information, or through x-rays or something like that. Education, we're seeing Kinect used to make education more fun and more interactive, all the way from pre-K and helping kids learn basic shapes and basic commands, up through this top photo here is actually from the University of Washington, Bothell, and they're using Kinect to gesture enable some graphing in a calculus class. And again, it's not going to replace pen and paper or other traditional learning methods, but it's a way to supplement it and make it maybe more engaging for students. And then manufacturing and training, one of the examples from there is using Kinect to train people to lift heavy objects correctly. You're supposed to use your legs and not your back, and so again, using the skeletal tracking information, they're able to. This one partner is able to give their employees very good training on that. So let me just jump back here to the deck. I hope that answered your question and gave you some examples to the person who asked that question. And definitely, if you have follow-up questions, please submit those online. Okay, so we did the Kinect Studio demo, although definitely had its issues. Didn't go as well as I was planning. Another question's just come in. Does the new SDK work with the old Kinect? And the answer to that is no. We've actually made the choice to keep those separate. So we have the most recent version for the original Kinect was the 1.8 SDK. So that's still available. You can still download that, and that works with the V1 sensor. The V2 sensor has its own SDK, and again, they're not. It's not designed to work with the old sensor. If you have more kind of context, Bob, about what you're trying to do, would love to hear that and see if we can give you some tips on how to accomplish what you want to do given the new model. So with that, I'm going to talk a little bit about something that we call Kinect interactions. And if you have an Xbox One at home, or if you've experimented with one, you may have seen this work. So we actually started this work on the Kinect for Windows team back with our 1.7 SDK that we shipped. And we didn't just say, oh, hey, we're going to do these gestures and we're going to allow people to air swipe or zoom or whatever that they would do. We really invested a lot in training, or sorry, in research and testing things and building a whole interaction model. So we talked earlier about these hand states, right? Open, closed, and then this lasso. I'm not going to go through these slides because I think we're getting short on time and I want to make sure to get through this stuff. But the interactions, we have this whole language essentially that we've built up. And so you think about there's this whole engagement thing, and you may have seen on the, actually no, you'll see this in the other sample that I'm going to do. We have this user view control that we use to show the person who's looking at or the person who's using the application to let them know that the Kinect sees them and what the Kinect sees, and you'll see this in a second. But we also have a way for if you're in a large screen display or if you're working with something at a distance, you can actually use gesture to target and to press or select objects. And then we've also done work so that you can scroll through lists and so that you can zoom in on objects. So if you're familiar with Xbox 360 or sort of the old version of Kinect for Windows before we did the interactions work, the engagement model is you would wave to engage. And now with Kinect for Windows V2 and with Xbox One, you look towards the screen and you put your hand in the fizz, is what we call it. And the fizz actually stands for the physical interaction zone. And then you open your palm to the screen. And again, the sensor is looking for those things to then say, oh, hey, this person is engaged and I need to respond to that. And this is definitely improvement over the old like wave to engage, because it's very deliberate now, and there is that sort of barrier to interaction. You don't want your application to start trying to respond to people's gestures. If I'm like looking over here and I'm talking to somebody, but I happen to like do this with my hand, it needs to be very intentional. Targeting and pressing. The old model before we did interactions was you would move the hand around and then you would hold it over the object that you wanted to select, and then there would sort of be that ring that would light up and it would take a couple seconds to select. And now what you do is you just target and you just extend your hand to press. And we also have done work. So the hand cursor, and again you'll see this in a second, the hand cursor actually fills up visually to give the user the indication of how far they have to go or how far they've gone towards the press. And then scrolling and zooming, in Xbox 360 you could do sort of like a swipe right and a swipe left. There was no zooming, and now with Xbox One and now Kinect for Windows V2, you grip your hand, so that grip hand state that we talked about earlier, and then you can actually physically manipulate the canvas so you can scroll this way, and then you just release the hand to stop something from moving. And then you can also grip the canvas and then you can zoom in and out by doing this gesture. So with that, let me jump over and show, actually I'll just show the Kinect interactions. And looks like we've got the app up and running. So if you notice there at the top of the window, the top center, you can see my silhouette. And so as I come up to, again, a retail screen or to a computer screen or wherever it is that I'm using this, I have this indication that the computer is seeing me and I can see what it sees. So if I just look at the sensor and I just raise my hand, we see the hand cursor now appear. And now I can come in and I can move that cursor around to target the different things. I can grip the canvas to scroll and to manipulate that. I can even flick it. So we've done some sort of physics to make it flickable, so you can scroll through a long list more quickly. But then if I wanted to select this object, I just extend my hand. And again, if you notice there, as I extend my hand, the hand cursor sort of filling in. So I just extend to select, and now I've chosen this particular, in this demo app, this page. And I have scroll again back in here. Now, because this is Windows 8 and it's a store app, I can still come in and I can still use my mouse. I can still touch my Surface Pro screen here to kind of go back and forth. If I wanted to jump back, I can still touch that control. So we're not saying or pushing and saying, hey, these interactions are going to replace touch or replace the mouse or replace the keyboard. In fact, we actually think that the world going forward is going to continue to be multimodal, right? So you'll have keyboard is great for entering text. You know, if you ever tried to use a touch keyboard on a device, it's not always the best experience. So keyboards are great, mice are great, touch is amazing, but again, interactions and using gesture, using your voice to control things, we think are really going to become integrated in the way that applications work and the sort of overall user experience. Tom's asking a question online, will the Kinect for Windows work with the Xbox One? So the answer there is, well, you may know that the Xbox One recently started shipping with, you could go and buy an Xbox One without the Kinect bundled in, right? And the Xbox team has said that they're going to start shipping a separate sensor, later sometime this year, so you could go and add the Kinect back if you bought the Xbox without the Kinect. We're actually using the same technology as the Kinect for Xbox One with Kinect for Windows V2. But the problem that you're going to run into is the plug, and I have everything's plugged in underneath, otherwise I would show you, but the plug for the Kinect is actually it's actually designed to plug into an Xbox One, so it's this sort of weird L-shaped plug. And part of what we're shipping with Kinect for Windows is not only the sensor, but we have an adapter box that basically splits that proprietary plug out to a standard USB 3 port as well as external AC power. So the sensors should work across the two, but the problem you're going to run into is you're going to need that adapter that again comes in the box with Kinect for Windows V2 to use that that Xbox sensor on a PC, right? So that's sort of the answer there. Another question that just came in is will or are these features already in the Xbox One? Aaron, if you could post a clarification there and give me more information in case I don't answer your question. I think what you're talking about is the interactions work that I just demoed. And it's absolutely already there in the box with Xbox One. So if you have an Xbox One or your friend does, turn it on as long as there's a Kinect plugged in, and you got to go through the Kinect calibration to make sure that the Kinect can see the floor okay in the room. But assuming that's done, if you stand in front of the TV with the Kinect and you just raise your hand like I just did, you'll see that hand cursor appear on screen on the Xbox One in the dash, and you can swipe, you can grip to swipe and scroll, you can target to select. Will the new gestures work with the V1 sensor is a question. We actually shipped, Jeff, we shipped those interactions that I just showed, we shipped those with our 1.7 SDK. So those are there that you can make use of with the V1 sensor, provided that you use 1.7 or a 1.8 SDK. The one thing that's not there in V1 is we actually didn't backport the zoom work. So that's not available out of the box. It's something that you could think about building on your own, but we definitely have the grip recognizer there. We definitely have grip to scroll. And then again, we have press and targeting and all that. So again, we built that work first on 1.7, and then we actually had the same engineering team improve upon that for Xbox One, and then now for Kinect for Windows V2. So again, if I didn't get the questions exactly right, let me know, and I'm happy to answer those again. So that's the controls basics sample. Now, actually, maybe another thing I'll show here real quickly is when you get our SDK, and we had this in V1 as well, we have what we call the toolkit. The toolkit comes with a ton of sample code right there in the box when you install. So for example, I could come in and say, I want to look at how I would get infrared data into my application. So I could come in here and I could just choose from the toolkit browser to run that application. So right there, I'm running this basic sample. Now the basic series that we have, those are really designed to show you the quickest, easiest way to get a particular data source off of the sensor. So in this case, it's how do we get infrared data as quick as we can off of the sensor. So this is this app. But the nice thing about all these samples, is, in addition to being able to run them, I can say install, and let me jump over here. So I just grabbed Infrared Basics WPF. I now have here the entire source code for that sample. So I can now open this up in Visual Studio. And now I can go in and basically steal this code and figure out how to start using infrared data in my application. So if I open up main window.xaml, it's just standard WPF application. Let me hit F7 here to look at the code. You can see here, we've got some using statements at the top here. We've got a bunch of variables that we're using for different things. The samples are well commented so you can understand what those are being used for. But if we go down here and we look, sort of the magic here is happening here in this method called reader frame arrived. So basically what this is doing is it's looking as frames are coming in, again 30 FPS off of the sensor, as these frames come in, this method's going to be called. And we can then say, hey, we're going to, we want to declare an infrared frame, so that's a particular frame type in our API, and we get the frame, or we use the frame reference to acquire that frame. And then we just have this nice using statement, and this is where, again, there's some other stuff in here that we're doing to kind of update the frames per second that you saw there at the bottom of the window and whatnot. But really what we're doing is we're just grabbing and we're saying, hey, if there's data there, if it's valid, then I want to just copy that frame data to this array, and then you can look at the rest of the code here. Again, it's all available in our toolkit, but then basically we're just taking that and then we're just going to write those pixels. Right here you can see in this method, or sorry, in this this function call, there's a bitmap image on our main window.xaml, and we're just basically pushing those pixels there and updating that window. So again, I ran it before from the toolkit browser, but now here I'll just run it from Visual Studio again so you can see it. So here it is, 30 frames per second, pushing those pixels to the bitmap there in main window. And then we've added this additional little feature just for fun where I can make screenshots and we just get them saved right to the pictures library. So if I go over here to pictures, we can open up and see that screenshot that I just took. So again, the developer toolkit, and you can come in and look by language. We have a whole section in here for our WinRT samples. The controls basic sample that I just showed is there. And the application that I actually showed first, where we were looking at all the various sources side by side, we call that Kinect Evolution, and that'll be in our developer toolkit later this summer as well. So you can go and use that for if you want to do demos. There's also going to be some nice reusable components in there if you wanted to use any of those visualizations for, like, say, Blockman or the skeleton and things like that. So it looks like we've got some other questions coming in. Actually, this is more of a statement from Chris. We would sure love it if you sold that adapter for those of us with Xbox Ones. Chris, I appreciate you raising that. We've definitely heard that loud and clear from other developers, even people in our developer preview program, and it's something that we're investigating the feasibility of. So it's something that we've heard before, and definitely something we're looking into. Bob V has a question: is the new Kinect for Windows available through distribution? For example, D&H. I'm not familiar with D&H, but the new sensor, actually let me just jump back over to my slides here and see how we're doing as far as, so I have one more section. So Bob, let me just say that I'm going to talk about that in a second. I've got a link at the end of my slides where you can actually go and you can pre-order the new sensor right now, and then it's going to ship mid-July in 23 countries. So I'm not sure where you're based, Bob, but chances are it's available in your country. And we're selling that sensor for $199. Again, it's the full kit. You get the sensor, you get the adapter, you get the power supply, everything in the box with Kinect for Windows V2, and it's going to be $199 in the US, and it'll obviously be in local currencies in the other countries. So let me just jump here. I've got video to show. I don't know if the sound's coming through. This is actually I'm just going to talk over this. All of these are applications created using a creative coding framework called Open Frameworks. And I always like to show this because I think a lot of us that have come from sort of the traditional corporate development side, application development side, we're not typically exposed to things like this. But Open Frameworks makes it really easy to do these really cool graphic effects, and manipulate pixels and do shaders and those types of things. A lot of the projects here in this video, not all of them, but a lot of them are using Kinect, actually the V1 sensor, to do these amazing interactive installations. And a lot of creative coders actually are more artists, and a lot of them don't even have a computer science background. And so we started working with Microsoft Open Technologies, or MS Open Tech as we call them, as well as members from the Open Frameworks and Cinder communities. Cinder is another library that's used in these sort of creative coding ventures. And we created this thing called Kinect Common Bridge. So Kinect Common Bridge is an open source project. You can go get it right now out on the MS Open Tech GitHub repository for V1. So if you go out there now, you can get it for V1. It wraps our native API, and it basically exposes it as a set of flat C functions that then are used inside of Open Frameworks and Cinder, and make it really, really easy to just get a frame and do whatever you're going to do in your application. So again, we worked with these communities because we heard from them, hey, we want you to make it easy for us to get Kinect data into these libraries and frameworks that we're working with. So we've already actually done a preliminary version of this for the V2 SDK. That's available, but you have to have the underlying SDK to use it. And then as the last note here says, we're actually currently working on support for processing. So if you're a developer out there and you're using processing, we're working to get support into processing. And then also we're investigating Unreal Engine 4. So if there are additional frameworks or libraries that you'd like to see us work with or get the Kinect data into. I mentioned Unity 3D is already there as well. We'd love to hear from you so that we can kind of think about that as far as our plans and work that we can do. So I've been given sort of the hook here. Oh, full screen on the PowerPoint. Sorry about that. We lost the, as I was kind of transitioning there on the video. Let me, well, I don't know if we're going to be able to get to full screen or not. Let me just pull up this next slide. This is my final slide, and I don't think that's what I want to do. Anyway, I hope you guys can read that. I think you can. These are some resources. So again, if you're interested in Kinect Common Bridge, there's the URL. If you want to get the official Cinder block or Open Frameworks plugin from those communities, those are the URLs for those. There's a Windows Store Open Frameworks sample code. And then Jeff was asking earlier about how to get his hands on a sensor now. There's the pre-order link, so aka.ms/K4WV2 pre-order. That'll show you the 23 countries as well as has direct links to the Microsoft Store in those countries where you can pre-order. Another plug here, On July 15th, Rob Relier and I, along with some other engineers from the Kinect for Windows team, are going to host a full live Jumpstart training. It's called a Microsoft Virtual Academy. That URL there is one that you can utilize to go and register for that event. Again, it's a full day. We're going to have multiple modules. We're going to go deep. We're going to show lots of code, lots of programming, lots of samples, and really go through the entire SDK so that you can walk away really knowledgeable about what's available, how you would go do things. And again, that's going to be live. It's a free event, free of charge, July 15th. And then finally, the Kinect for Windows blog is a great place to keep your eye on if you want to know, when the beta SDK ships, when the final SDK ships, and things like that. So with that, I'm going to close. I put my Twitter handle here. If you want to get in touch with me on Twitter, it's @BenLauer. And I really thank everyone for your attention and for joining us today and for the questions coming in. I'm going to hang out on the Jabber right after this for a few minutes. So if you have some more questions, I can hang out there and answer them there. And again, thank you very much.